Okay, and now we will start the third presentation. This will be done by Alexey Zhebel and Nickolay Ihalainen about tuning Linux for your database.
Okay, hello everybody. As we already introduced, I'm Alexey Zhebel and Nickolay Ihalainen. We're from Percona, and today we're going to talk about tuning Linux for database workloads. This is a talk that was originally created by Colin Charles, who's our chief evangelist at Percona, but he's very busy and goes to conferences all over the world, so he couldn't be here. That's why we're presenting his talk. And this is us. I'm a technical writer at Percona. I do documentation for our open source software. And Nickolay is our senior technical services engineer. Has a lot of experience with solving various cases and tuning databases. So all the questions that you might have in terms of our talk, you can point to him. This is our rough agenda, the topics that we're going to go over. And one thing I've got to tell you is that this talk is not really anything new. It is just a compilation of best practices and ideas, something for everyone to start with when dealing with your database workloads. The focus of the talk is the focus of the talk is Linux, and there are many distributions of Linux, so you got to understand that we can't cover everything in one talk. But usually most of the database workloads are better off on Red Hat derivatives, such as CentOS. So that's what we'll mostly focus on this talk. Okay, this microphone doesn't work. Okay. Hello. Okay. Yep. I'll try here. Yeah, this is good. So, yes, in older versions of Red Hat, in version 5, for example, there was a tool called Ktoon. For version 6 and later, you have TuneD, which has been greatly improved in version 7, so that's something that you should start with when you're preparing your database, when you're preparing your hardware for the database. And you can do most of these things on Debian-based distributions as well, but you'll have to do a lot of manual configuration because they don't have the TuneD or Ktoon or anything like that. But it's basically like some tuning profiles. So you can do it. So when you're considering hardware for the database, you'd usually first think about the CPU, then memory, and then think about it in terms of I/O. But you should really focus on I/O the most because that's what databases are all about. They love a lot of I/O. So you have to think about the storage system and subsystem. That's what we're gonna focus here. The type of storage. Spinning disks are not always a bad choice. They can be a good choice for streaming data. For example, ScaleDB can benefit from using spinning disks. And network storage is not as much about I/O as about latency in your network. So you have to make sure that you get least amount of latency. And we'll talk about SSD and flash storage and Fusion I/O and all that later in the talk. You got to understand that modern engines such as TakuDB, InnoDB, and RocksDB, they all have compression. So when you're using modern storage systems, you've got to make sure that you make use of that compression, so that you can get more storage out of it. Next is about I/O schedulers. The default scheduler is CFQ. It is all right for slow storage, and if as an alternative, you should look at no-op elevator and deadline, which is used a lot more in database workloads, and most databases will benefit from deadline because it has 2 queries per device, one for reads and one for writes. So we can look at quick benchmark comparing deadline to CFQ. This is an old benchmark. It used MySQL 5.5, which didn't have group commit. So you see that difference between the 2 deadline cases with and without this flush log at transaction commit enabled and disabled. For modern MySQL, you wouldn't see that much difference, but the important thing to note here is that deadline is generally better than CFQ, and no-op is on par with deadline, so you won't see much difference in those. When you think about file systems, you generally want to choose between ext4 and XFS. You probably don't want to use HFS Plus like used on MacBooks, because Macs are not really good for database workloads. Also, lately, ZFS is becoming more popular. It's been used mostly by BSD folk before, but it is included in recent Ubuntu, for example, and it's getting more and more production workloads. So you can look into ZFS and BTRFS, which is based on ZFS. So it's something that you might want to look at. When choosing the file system, you have to obviously understand your mount options. So reading the manual page for mount is important. And as you can see, here we recommend turning off barriers in either case, which is an important option here in any case, because what I/O barriers do, they make sure that the journal is written to your file system, and this keeps your data safe. But at the same time, if you use it, then you can't use like caches. So it is better to turn them off. And a quick benchmark with about 1.6 million SQL rows showed that with barriers enabled, the dump took about 527 seconds, while with barriers turned off, that time went down to about 21 seconds. So it's like 20 or 25 times better. And also InnoDB can flush pages at a much greater rate with barriers disabled. It's about 80 megabytes per second compared to 4 megabytes per second when the barriers are enabled. There are also other options that you should probably look at, but as I said, you can look at the man page and learn about mount options there. Okay. SSD and flash memory. The obvious advantage is that you get a lot more IOPS than traditional disk, low latency. But you have to make sure that you're using a new RAID controller, because the old controllers are really optimized to reduce random I/O. They don't expect that much IOPS, so which is why you have to ensure that the new RAID controller is used. And also some words about the double write buffer. InnoDB uses shared double write buffer between all the buffer pool instances, and so when it flushes the buffer, the writes are blocked until it has to finish. For example, so you can either disable the double write buffer, or in Percona Server 5.7 you can use parallel double write buffer, which is a private buffer for each separate instance. So that's an advantage there. In terms of RAID, this really depends on the number of disks you're using, but you probably should strive for RAID 10 and use it with 4 or more disks. And then if you have more, then you need to look into other options, like maybe even RAID 50 or RAID 60. One note is that if you're running Hadoop, then don't run RAID on slave nodes, because Hadoop actually orchestrates data redundancy. So you will only need to have RAID on master nodes if you're doing Hadoop workloads. So LVM. The obvious advantages of LVM are that you can easily expand the disk and take snapshot backups, but there are ways to get logical backups. For example, with MySQL dump, which is included in MySQL by default, and you can get physical backups with either some enterprise feature or, for example, Percona extra backup. But if you're stuck with some engine that can't do either logical or physical backups, then you need to do LVM. For example, MongoDB only has enterprise level backups. So if you're not if you're using community version, then you're going to need to use LVM. Also, Hadoop doesn't recommend LVM because of the latency, and it becomes a bottleneck for it. And the penalties that you take from LVM are about 2-3% for each backup, but the first backup usually over 40%. So consider it and take into account. Memory. All modern servers are NUMA capable. They come with NUMA, and you have to deal with what is called swap insanity. This is usually a big problem on large systems. For example, if you have like 64 gigs of RAM and an InnoDB buffer pool size of 48 gigs or more, then Linux will decide to swap some potential amounts of memory, even though there is no real memory pressure, and this swapping can really be bad. So you should switch to interleave equals all. So you do NUMA control -- interleave equals all for mysqld. Or if you use Percona server, starting from version 5.6, there are actually options that let you control swap insanity. This is just a list of things you have to remember when you consider the memory usage for MySQL, where it's used, like in session buffers for statistics, like index stats, user stats, and also client stats, and obviously MySQL needs to cache data, so need to think about it there. And this is just a list of other places that you need to make sure that are covered. File system cache, MySQL cache. Again, there are variables that you need to adjust, and you can always run free-m to see where your memory is used. And inside MySQL, you can do show engine and ODB status, which again will show you where your memory is going. Transparent huge pages, pages of 2 megabytes or even sometimes 4 instead of the standard Linux 4 kilobyte pages. MySQL generally benefits from enabling huge pages, while, for example, MongoDB and Redis will not. And in the latest Percona server, which runs TokuDB, we actually recommend to disable huge pages. It's just because of the implementation behind TokuDB. It uses JE-malloc that calls madvice instead of regular malloc. So that's why we recommend disabling it. But if you're running MySQL, then you will see great benefits. Swappiness is something that everyone recommends to disable. So set VM swappiness equals 0, which is not a good recommendation for modern Linux systems, because they will call out of memory killer, which will probably kill your MySQL D process. So instead of setting it to 0, you can set VM swappiness equals 1. Just set it to the minimum amount of swappiness without disabling it completely. CPU, the power scheme. Don't leave it at the default on-demand power scheme. Don't activate the power save scheme. It is generally better to use the performance scheme. You can set it at runtime with an echo like this. Also, make sure that you check your BIOS settings and pass on all the power control to your operating system to be able to use this. In terms of network, as I already mentioned, you need to make sure that you lower your latency. The tools that you can use are traffic control, which shows and lets you configure traffic control settings. Dropwatch to monitor packets that are dropped by the kernel. TCP no metric save equals 1 is something that we enable so that TCP doesn't save the state when the connection breaks, because usually it will cache the state so that when it reconnects, it can use it as some initial parameters. But if you do this, then it will not do this caching and increase your performance. ARP is important in many setups where you have 2 network cards and you're running your queries across your private network and you don't want them to go over to public. So you need to enable the address resolution protocol to avoid this. Jumbo frames can be good for example, data warehousing use cases. Things like DRDB and DB cluster, Cassandra and HBase all benefit from setting max transmission unit size to 9,000. And you can use sar-n dev to see network statistics. Here are several other things that you can tune. Either use the configuration file or you can do it runtime with Neko. So you can allow more connections to queue up, increase kernel packet buffers, increase socket connections, and reduce TCP timeout after closing a socket, if that applies to your system. Some final thoughts. When you're running a fully synchronous replication, like for Percona XRDB cluster or Galera cluster and DB cluster, remember that the whole cluster is going to be as fast as your slowest node. So you have two really powerful servers and like a third node, which is just your oldish laptop. Then the whole cluster will need to wait until that little laptop will synchronize with everything else. You can also leave one network card for transactions and route your GCOM traffic to the other network card. GCOM is Galera Cluster Communication Protocol. Also, tune the EVS protocol for auto eviction. So the number of data packets in replication at a time should probably not be more than 512. Resource limits are important when you're trying to get core dumps. The default limits are usually not enough, so you need to raise them. Here's some values that we recommend. Also, default resource limits may be too low for MongoDB because it uses one file descriptor for each data file, which is in use by MongoDB, and one file descriptor for each journal file in use by a MongoDB instance. So again, you'll need to raise the limits, and you can check your limits with this command here. Besides tuning Linux itself, you should think about how to configure the database and your database server. So need to look for slow queries to fix them. You can use your slow query log, run it through PT Query Digest. PT Query Digest is a tool from Praktica Toolkit. Use it to analyze your queries and find what's slowing your database down. Also, we recently released Percona Monitoring and Management, which is a better solution, more visually appealing, and it's like a web interface, which has all this data but presented in graphics and everything. It's just easier. You can use things like MySQL Slap again. It's just the default tool for MySQL. And remember not to run your database server with default settings. Look at your configuration file and don't just assume that they will be good enough as default. We probably don't have time for topics on virtualization now. So we're gonna skip. Yeah, okay. But we still have a lot of slides after it. So containers and cloud. Percona server is, I already mentioned some of the features in Percona server that will help you with the database workload that you're running. So here's just a list of what's already been talked about. As for hardware overall, don't forget to test your hardware before you run it in production, because both network cards and disks, they all can come in bad batches. The drivers can have bugs if you're running an old distribution. It might not be compatible with the latest hardware. So make sure that you test it before putting it into production, because then you'll probably blame something else for the problems, and will never come back and think about your hardware, that it might just be some errors in the hardware itself. Hadoop and HBase is very problematic in the cloud. So if you run it there, then you'll get a lot of noise on the network, which is not recommended really. Again, you need to increase the resource limits and make sure that the name resolution works. So there's also a good link that we provide with some hardware recommendations for Hadoop and HBase. In this talk, we mostly talked about mysql, but mentioned other databases as well. They all have some kind of tuning guides for the operating system. So again, you can always refer to those tuning guides for help and guidance. SELinux is another thing that everyone recommends to disable. In our documentation, we also say just disable it and run it without SELinux, but it's really not what it was developed for. I think most of you probably understand it, and this is why there's a whole website on the internet dedicated to just that problem, that you have to learn it, learn how to use it, set up the profiles correctly, and it's much better. AppArmor on Debian-based systems is the same as SELinux. It's something that everyone says, just disable it and forget about it. But that's not how you should deal with it. So that's a list of tools that you should have in your arsenal and that you should learn if you want to prepare your system for a database workload. Praktica Toolkit is something that I mentioned before, PT Query Digest, and there are a lot more different tools that will help you with the tasks of configuring and properly tuning the system and the database. There are, I think, over 20 different tools. And Percona monitoring and management, we actually have some handouts dedicated to Percona monitoring and management. You can look at it, and we have a whole demo website with all the graphics and everything you can do in it. So make sure to take one after the talk. Benchmarking, again, it's just a list of the benchmarks that you can use. Sysbench is an obvious choice for everyone. But there's also Linkbench, Yahoo, and Google also provide their own benchmarking solutions. The books on the topic. Take a picture if you want. Percona Live 2017 is a conference that Percona is organizing in April 24 to 27. If you have a talk for Percona Live for the biggest open source database conference, then you can submit. You have a couple of days left, and please do. And also, Percona is hiring, so if you have anyone you know that is into databases or software development in general, we have like literally dozens of open positions. So if you recommend someone to us, then you'll get, and he gets hired, you'll get $1,000. And that's it. If you have any questions.
Thank you for your presentation, and now time for question. Okay. You?
Can you please explain your advice about using ECC memory? How can it be faster? And first of all, it's costs more than non-ECC memory.
Yeah.
What the pro?
Here. Yes.
So this is actually easy. With ECC memory, you're actually spending some amount of performance on ECC itself. But it could be two kinds of ECC usage. The first one is just make sure that you will not corrupt your data on disk. And this is the most important for databases and especially for relational ones, to not corrupt your data. And the second usage of ECC memory is correct memory errors and allow to work for server even if there is a memory fault. But this is usually not a problem for databases with replication, because with replication we can just shut down instance with corrupted memory and forget about it until hardware will be replaced. So if you are asking just for ECC memory, yes, it's slightly reducing performance.
Okay, thank you. Next question.
Do you have some best practices or recommendation if I need to have our database encrypted?
Okay, for encryption there are two options. You can use encryption function of database itself, and it could be better because you can encrypt only a part of your database, or just several columns, for example. But in most cases, if encryption is required, in most cases it's caused by PCI thing. And because of that, you should encrypt your disks in most cases or whole database. And for this case, there is a problem. With encrypted databases, we increasing the latency for writes. And if we increase in latency for writes, the best idea is do not use flash often. For example, for binary logs, it's a good idea to not sync binary logs or make sure that group commit is used for MySQL. And you can also disable sync for each commit for each transaction if this is a problem for you.
Thank you. And next question. Andrew. Okay.
So you say that deadline is the best I/O scheduler for performance. This fact is a little bit controversial. I mean, there are other documents, places where it is stated that no, this is not true, CFQ is better, no, NOP is better, and so on. Could you please elaborate a little bit more about your statement?
Yeah, there are different cases, and I think Nickolay can explain where CFQ, for example, might be better.
Okay, CFQ is actually a good I/O scheduler in terms that it allows to share I/O bandwidth between many processes or many applications. But in terms of performance for databases with single process and multiple threads, it's not effective because it contains many redundant things like I/O priority for MySQL. It's not useful at all because we have only a single process. And another issue that there is a bug inside ext3 and I think ext4. If we have a CFQ and making a lot of IOPS to a single file like InnoDB table spaces, this IO will be serialized, and this is a problem. And for modern storages, for NVMe, for example, none of I/O schedulers applicable because all I/O schedulers, including NOOP and Deadline, actually both having almost the same performance. For modern flash storage, we need some new subsystem inside kernel to get benefits.
It's there. So
Okay,
blockmq is the answer for new storage systems.
Okay, thank you. And next question. Вопросы по-русски? Okay.
You mentioned about double write. There is any cases where we can avoid it or disable?
Okay, what is double write? If we have a database page, we should be sure that a whole page will be written to disk. And in order to make this thing available, I need to be writing the page to table space and to special part of main table space, double write buffer. And this could be redundant on storages that allows to guarantee that we will have a whole change on disk even for page bigger than block size. And with atomic locks, it's possible for Fusion IO. But as I understand, this feature is not implemented for a significant amount of other storage from different vendors. And this is a specific feature for Fusion IO. And for other things, you should have double buffer enabled to avoid partial pages update.
Okay, one additional question.
Yeah, but what about solving on a file system level, like Ext4 with data journal mode or ZFS or BTRFS?
Well, journaling, solving this thing, if data is also journaled. By default, most of file system journaling only metadata changes. But if we enable journaling for Ext4 or Ext3, we actually getting almost the same feature as INDB double buffer. But I see a blog post with this advice, with 15% improvement for performance. And after this blog post, I see that some guy is trying to enable data logging on Ext3 and finally got a corrupted database. So this should work, but it's not as stable as INDB feature.
Okay, thank you. More questions? I think that as we have time left, probably a couple minutes, probably you can go through slides that you skipped to save time. It's about containers and others. So what do you think? No? Okay, in this case, thank you very much for your presentation. And it will be next break. We'll be here 5 to 6. Thank you.